Hi, good morning to all of you. Welcome you to all for the second day two of cable selection and sizing workshop. So, yesterday we discussed about few basics on cable selection, like what are the different types of cables and types of insulations, armoring, and cable nomenclature. Okay, and also we have initiated how to do the cable sizing calculation. So I just want to know, like all of you are with me now. Is it audible to all of you? Can you just say yes in the chat box? I just want to say your just yes in the chat box. Great, thank you all. Yesterday we discussed about cable selection. And today we are going to discuss, understand various important things because, like, we have to know what are the different criterias to be followed for the cable sizing. Depends upon the connected load and all. Today is a very important session, and this will be very useful for your career. So, guys, I request you all, please keep a scientific calculators with you. Whenever I ask some calculations, I'm just expecting values, answers from you guys. I hope you're ready to give me the answers, right? Am I correct? Yes, thank you so much, all of you. So here, now let's see, like, what are the this cable nomenclatures and all we have seen yesterday. It's very clear. Now we have to know cable, what are the parameters decide cable size. So this is very, very important interview question. When you go for any interview, most frequently people ask you the question, what are the parameters decides cable size? So your answer should be very simple, like a current carrying capacity and a voltage drop and the short circuit withstanding capacity. These are the three parameters decide cable size. So now the point is, in this also, like, I'm just taking you people into a bit in depth into the concept. Like, in electrical system, we have like LT cable sizing calculations and HT cable sizing calculation. So I'll make you understand today about LT. In the LT cable sizing calculation also, like, what are the parameters to be decide for incoming feeders and what parameters to be considered for outgoing cables and what parameters shall be considered for HT cable. So these three calculations you are going to learn today. These are very, very important. Now let's get into the calculation parameters for LT outgoing cable size. So guys, I'm telling you again, this session will be available in the YouTube channel. We are available in the YouTube channel HIW. So you people, I request you all, you can go through our YouTube channel, you can subscribe and you can share and you can, there are many more knowledgeable sessions available with our YouTube channel. Guys, you can go through later on this session and you can understand, note down the points and all. So for parameters for LT cable sizing calculation, for outgoing, we have like a certain criteria for LT incoming cables and outgoing cables. So now I'll make you understand what parameters decide LT outgoing cables. I'll just show you one SLD now. With that, you will understand what do you mean by incoming and outgoing cables. I'll just make you people understand this more in a more practical way. So that's the reason I'm taking all real-time examples. So when I'm swapping from one page to other page, it takes a few seconds time. I need your patience to wait for that. Guys, see here, this is one complete SLD. We call it as a single line diagram. Single line diagram of ACDB, AC distribution board of one 220 by 33 kV substation. So in 220 by 33 kV substation, we say like this is a incoming feeder, like this is a transformer, and this is a DG, diesel generator. Okay, so this is a transformer one, and here this is transformer two. So these two feeders, whatever the cable you are connecting here, whatever the cable you are connecting here. So these are called incoming cable. Okay. So, and here, so what is the cable here? We have, you can read this 3.5 core 95 square aluminum XLPE armored cable. This is a incoming cable. And from transformer 2, this is the transformer. So we'll discuss, I'll keep one more session about transformer later, guys. So for that, my request to all of you is, if all of you have LinkedIn profiles, whoever is having LinkedIn profile, can you just say yes? Because LinkedIn is the professional social media. So I request to all of you, please create your LinkedIn profiles and please do follow HIEE. You just type in the LinkedIn HIEE, then you will get the page, and you please follow us through LinkedIn, and we are also available through Insta like HIEE core jobs. So the advantage of following us through LinkedIn and Infra is you will get all the updates, whatever the free webinars, whatever the knowledgeable sessions we are planning. So it will be easy for you to access through HIW directly. So I request you all today, you please go through, and we have also given our LinkedIn page in the chat box. So please follow us in the LinkedIn, and also please follow us in the Insta for further upcoming knowledgeable sessions. So next session I'm going to make on transformer selection and sizing free session. So like that, every week we'll plan something to make you people knowledgeable in electrical segment. Guys, so here if you look at, this is an incoming cable from transformer to ACDB. Here you can read out this like how to read this cable. This is like a two runs of 3.5 core 300 square aluminum XLPE cable. So here two runs of 3.5 core 300 square So this 300 square cable conductor size we are going to see now on what basis. This is the incoming cable. So in the LT, this is all LT. This is 11 by 415 volts or 433 volts. This is LT side, like a low voltage side. Okay. So in the LT, you have incoming cable and outgoing cables. So what parameters we check for outgoing cables and what parameters we check for incoming cables? I'm going to make you understand in a simple way. Right? So here, this is an incoming cable and these are all outgoing feeders. You can see here, these are all the outgoing feeders are connected on the bus. So based on the connected load, for example, I'm telling you here, I'm going to connect this cable to, let me take indoor ELDB. Indoor ELDB is nothing but indoor electrical emergency lighting distribution board. And the load is 4.5 kilowatt. For 4.5 kilowatt, what cable we are using here, what cable we are connecting here? 4 core 16 square aluminum XLPE cable. most of the power cables we keep XLPE is the insulation. Power cables we generally go with XLPE insulation, and control cables we go with PVC insulation. XLPE stands for cross-linked polyethylene. PVC stands for polyvinyl chloride. So I request to all of you guys, you please inform to your friends whoever is missing the session, because this this session would be the most important session, I'm telling you. And somebody is ping the chat box like they didn't get the certificate yesterday. Don't worry. So whoever is attending 2 days workshop, yesterday and today, so you will get 2 days workshop after completion of this session. Okay, so you nothing to worry. Everyone will get the certificate. Only thing is you have to fill the feedback form, and also you please check your spam on Monday. Sometimes whenever we are sending the mails, it will goes through spam. So you please check your spam. So still, if you are not finding your certificate, you can contact our people with a given number in the chat box. So nothing to worry. So let us focus on learning. Okay, nothing to worry on about certificate. Done? Yes. So these are all the outgoing cables, and this is the incoming cable. Now the point we need to understand here is, for 18 kilowatt load, they have mentioned 3.5 core 70 square mm aluminum XL. Like, on what basis we are doing the conductor size? What is the basis for selecting the conductor? That we are going to understand for incoming and outgoing cables and HD cables. Done? So can we move forward? Yes. So now I'll just take you through one by one, step by step procedure. Okay. So like for LT cable sizing, it depends on two parameters. One is like a current carrying capacity and voltage drop. So let's understand first. Okay. um, how to decide the conductor size based on the current carrying capacity. Guys, let us go in a very slow and systematic process. And if you don't understand anything, please ping in the chat box so that I will clarify your doubts at that moment. Okay, please be alert. Okay, and just follow the procedure. Thank you. So current carrying capacity, here the current carrying capacity of a cable correspond to the maximum current, because always we have to decide the cable size for the maximum current flowing through the conductor. So always you have to do the cable size for the worst condition, so that it can carry under specific condition without conductor exceeding the permissible limit of steady state temperature for the type of insulation concerned. Depends upon the insulation. So here the point is, here, before going to make you understand the current carrying capacity, what you have to know is you should know how to go through the cable catalog, because there are many cable manufacturers in the market. So whoever the cable manufacturer you are selecting, so first you should know how to read their catalog. Once you know how to read the catalog, then you will understand how to decide the conductor size based on the current carrying capacity. So guys, first what I'll do, before making you understand the current carrying capacity, I will explain you a sample cable catalog first. Once you understand that, then these are all becomes very easy for us to understand. Is it clear for you, all of you? Is it okay? Please, yes. Am I clear with you, all of you? Yes. Now, so I will just show you and make you understand the cable catalog. So generally, I'll take always because polycab cable catalog I consider because that is very flexible to explain to make you understand, guys. So this is a polycab. There are many manufacturers in the market. Not only polycab, you have Ducab, you have Havels, you have KEC, and there are so many cable manufacturers. Okay, any case because any manufacturer, it doesn't matter. Only thing is you should know how to read the catalog. That is very important. So in any cable catalog, this is all about their product and all. Okay, like you can go through your Google and you can download this catalog. So first thing is here in this it is mentioned like comparative current ratings of some cables. So this is not required for us. For doing the cable sizing calculation, we need how to take the conductor resistance, reactance, and how to decide the current carrying capacity of the conductor. These three parameters we need to know here. Yes. So for knowing this conductor resistance, so here it is mentioned conductor technical information for single core and multi-core cables. Okay, it doesn't matter whether it is single core or two core or three core. Based on the cross-sectional area of the conductor, based on the cross-sectional area of the conductor, this is like a nominal size of the conductor. Starts from 1.5 square mm, 2.5, 4, 6, something like almost like up to 1000 square mm is a conductor. So this is the conductor size. For example, you are going with a 25 square mm conductor. If it is 25 square, like I told you, we use two types of conductors, aluminum conductor and this Cu stands for copper, ALU for aluminum. Okay, and this is number of wires and this is compacted and round shaped. It's okay. Like you have two things. One is like a DC resistance and AC resistance. So when you are doing AC cable sizing calculation, when you are doing AC cable sizing calculation, we have to take AC resistance. If your application is a DC application, then you should consider DC resistance. This is one point. So just a minute, based on, sorry for the interruption, guys. Just a minute. Yeah. So based on the type of conductor material, and whether you are going with the aluminum or copper, and based on the cross-sectional area of the, for example, if it is 25 square mm, then for aluminum conductor, your resistance you have to take, this is 1.54. Units are very important here. 1.54 ohms per kilometer. That is very important. Ohms per kilometer in the sense for the cable length of 1000 meters. For 1000 meters, the conductor resistance is 1.54 ohms. This is for aluminum. And if you are going with a copper conductor, this will be 0.930 ohms per kilometer. This is very important. Units are very, very important. I'm telling you. Okay. So this is how we consider the conductor resistance. And the next point is here. This is very, very important here. How to consider the current carrying capacity of the conductor. Here we have, I told you, like we have like a single core cables, two core. Depends upon your application. Depends upon your application. Here, this is I'll clarify all your doubts in the ending of the session. Please um, keep your doubts. I'll give you time because if I get into the doubt session, then main content will get deviate, Mr. Balaji and all. So please keep your doubts. Please make a note of it, and we'll discuss one by one in the ending of the session. I hope you understand. Thank you so much for your understanding. Yes. So this is a single core cable. You can single core aluminum conductor XLPE insulation. This is the cable. You can see here. So this is the cross-sectional area of the conductor. These are all the parameters of the cable. And here, okay, here your doubts here, this is the current rating of the conductor. Depends upon the laying method. When you are laying cable in the ground, what is the current carrying capacity? When you are laying the cable in the air means above the ground, what is the current carrying capacity? Okay, so this is called current carrying capacity of the cable. Current carrying capacity of the cable based on the cross-sectional area of the conductor. If it is 25 square mm is a conductor, if you are laying the cable in the ground, then your current carrying capacity is 96 amps. Units are very important, I'm telling you again. 96 amps. If you are laying the cable above the ground, then it will be 98 amps. Okay, so there are many parameters here, guys. I'm just touching the important parameters because if I started telling about all the parameters, to complete 1 hour will be wasted only in understanding the catalog itself. So I'll just give you the glimpse on important points. This is single core and aluminum and single core copper. You have like all two core aluminum. You'll see two core looks like this. You have two conductors in the two core cable, aluminum and copper. Next will be three core aluminum conductor, XLB insulated, three core copper conductor, and three and a half core. Three and a half core in the sense you have like R, Y, B, and N. So here the neutral conductor is half of the phase conductor in case of three and a half core, and whereas this is three and a half core aluminum and this is copper conductor, and four core aluminum conductor. Four core. What is the difference between 3.5 core and 4 core is in the 3.5 core your neutral conductor will be half of the phase conductor, and in the 4 core cable phase and neutral conductor both are same. Okay, cross-sectional area of the conductor is same. So it depends upon the application, whether you are selecting 3 core cable, 3.5 core cable, 4 core cable, or single core cable, whatever the cable. Based on the conductor size, based on the number of cores, we have to select the current carrying capacity of the conductor based on the laying method. When you are laying the cable in the ground, these are the current carrying capacity of the cable. When you are laying the cable in the air, this is the current carrying capacity of the cable. So now, once you understand, and this is a 4 core copper conductor, and these are all multi-core cables, multi-core control cable with a solid copper side and all. Yes, generally sharing these documents and all, this document is available in your Google, guys. Okay, if you just type Google like Polycab cable catalog, you will get this document. It's not a big deal. Okay, so that way I can give you the reference and source from which you will get the documents. Okay, and one more thing is yes. Now, so far in the cable catalog, we understood one is like how to decide the resistance and reactance and current carrying capacity of the cable. And here, these are the rating factors. These are very, very important. These are called derating factors of the cable. Derating is nothing but oversizing of cable. Derating is nothing but overrating of cable based on the actual laying. For example, here, for example, if we are laying for air and ground temperature, if you are laying the cables above the ground, if you are laying the cables above the ground cable is designed for 40 degrees centigrade. When the temperature is 40 degrees centigrade, your derating factor is 1. It means the cable is designed for 40 degrees centigrade above the ground temperature. And if you are laying the cables below the ground, underground cable, the cable is designed for 30 degrees. If the ground temperature is, for example, 40 degrees, then your derating factor is like a 0.91. What does it mean? 0.91 in the sense the current carrying capacity of the cable is going down by 10%. Current carrying capacity of the cable is going down by 10%. That is the effect of ground temperature. So like that, we consider various like a depth of laying. So I'll just explain you one by one. Okay, I'm in the calculation document. Depth of laying and variation in the soil thermal resistivity. So these are all the derating factors, and here group rating factors. Okay, so these are all the factors we consider for cable sizing calculation. Okay, so guys, there are various scenarios. Okay, there are various scenarios we need to consider cable size. So I will just again go back to the sizing calculation sheet. I'll just make you understand one by one. This is how a typical cable catalog looks like. So you should know how to read the cable catalog. So after the session, you please download the catalogs from the Google and try to understand that. Yes. So now I'm coming to the point. So derating factor, like a current carrying capacity of the cable, we have to consider the derating factor. Yes. Thanks to Pawan Kumar, he is helping you a lot in finding out and giving you the cable catalog. Thanks, Pawan. So, derating factor or correction factor shall be applied where the installation conditions get differed. So, your derating factor, I told you, derating is nothing but oversizing of the cable. Derating is nothing but overrating of the cable based on the actual laying conditions, whether you are laying underground or above the ground. Okay, here it is mentioned. Derating factors are defined as the factor which consider the parameters during installation so that appropriate cable is selected with a suitable current carrying capacity. CCC is nothing but current carrying capacity. Now we have to consider what derating factors we consider for underground cables and above the ground cables. How does a derating factor is considered? Okay, so derating factors are considered based on the cable laying methodology. As I said, like a cable laying methodologies, we have like above the ground and underground. So, for example, derating, what are the derating factors are considered for underground cables? Generally, this also one interview question people ask you. So, what derating factor we consider for underground cable laying? Guys, these are the factors we consider for underground cable laying. That is grouping factor, depth of laying factor, ground temperature. This is effect of ground temperature. I have shown you now. At 30 degrees centigrade, your cable is designed for the ground temperature of 30 degrees centigrade. If the temperature, see here, cable current carrying capacity mostly will get affected by the temperature. Your temperature is directly proportional to the resistance. Your resistance is inversely proportional to the conductance. Okay, so these are the derating factors. These are the derating factors we are considering when you are laying the cables below the ground, underground. Group rating factor, depth of laying, ground temperature, soil thermal resistivity, and also we consider design margin. Clear? Now let's understand one by one what do you mean by group rating factor, what is depth of laying, and what is everything. Group rating factor is this means if whatever it is, whether it is, for example, if you are laying the cables below the ground, generally we have the cable bedding and all. So how we are laying the cables below the ground? So whether you can see here, you are laying the cables by touching each other or you are maintaining some distance between the cable. So it impacts the conductivity of the cable. I'll just tell you, yes. So I'll tell you, for example, what happens here if the two cables are touching each other like this, when the current is flowing through the conductor, so your cable will get heated up because of losses and all. So this temperature will get impact on your adjacent cable when both are touching each other. For example, I can tell you, like for example, if you are traveling in a bus, if your bus is filled, like if it is packed, then what happens, like because of temperature and all, because of suffocation, everyone will get the sweating and all, and you feel like you're losing the energy. The same thing happens here. If too many cables are touching each other because of the temperature issue, what happens? These cables also will get suffocated. Means when the temperature increases, your conductivity will reduce. So that's the reason you should consider how you are laying the cables, whether you are laying the cables by touching each other or you are laying the cables by maintaining some distance. So if, for example, in the bus also, if everyone is sitting in the respective seats, then what happens? Air circulation will be very free, and you don't feel like you have you don't have that travel nervousness. But the same thing happens to the cable also here. If you are just maintaining the distance, there is a air circulation. So when the air circulation is free, then what happens? The temperature will comes down, then conductivity will improve. So that is called the group rating factor. So, and the next is grouping factor. So this is how we are laying the cables by touching each other or by maintaining some distance. That matters a lot here. So group rating factor, here it is mentioned. Again, this is for single core cables and multi-core cables. Okay, depends upon, there are so many criterias there to select the group rating factors for single core cable, and this is how one way of laying the cables. So this is underground cable will be laid like this by maintaining some distance between cables. So this is group rating. And here, if you are laying the cables through conduit, so in the conduit, what happens? All the cables are touching each other. This criteria will be different again. So depends upon the different criterias, we select the group rating factor. So when it is laying above the ground, like these are the cable trays we use to lay the cables. And this is how in the industries cables are laid. Depends upon the requirement. These are the various pictures. You can understand how we lay the cables in the industry by using cable joints and all. This is one. This is above the ground cable will be like this, open to air. There is a air circulation within the cables. So this is called group rating factor. Once the group rating factor is done, then what is the depth of laying? Depth of laying in the sense, at what depth you have to, what is the minimum depth of laying of conductor to maintain the conductivity. So in the depth of laying, generally depends upon the voltage level. We prefer what should be the minimum depth of laying. Generally for low voltage application, LV cables, the depth of laying should be 750 mm below the ground. This is very, very important, guys. So the depth of laying of the cable, for LV cables, we lay the cables below 750 mm below the ground, and 3.3 kV to 11 kV cables, we lay the cables at 900 mm below the ground, and 33 kV cables are laid below the ground 1050 mm. Okay, this is a LT cable, and these are all the medium voltage cables, and above 33 kV. Above 33 kV, every 33, like above 33 kV level, for every rise in 33 kV level, your depth of laying is going to increase by 300 mm. For example, if it is, let me take 132 kV cable, you are going with the UG cable, underground cable. So what is the depth of laying here for 132 kV? Can anybody tell me? What should be the depth of laying for 132 kV? For every 33 kV, I told you the depth of laying is going to increase by 300 mm. What should be the depth of laying for 132 kV? Guys, 1950 is the right answer. Okay. Yes. So like that, when you are increasing every 33 kV, the depth of laying will be increased by 300 mm. This is how we decide the depth of laying based on the voltage level. For LT cables will be 750 mm and 3.3 kV to 11 kV will be, it will be like 900 mm 1050. You just remember that in your mind. Next will be effect of ground temperature. Okay, what we discussed so far, effect of ground temperature depends upon the laying methodology. If you are going with the above the ground or underground. For above the ground cables, at 40 degrees centigrade, your depth of laying will be 1. Means these polycab cables are designed for the above the ground cables for 40 degree centigrade. Okay, and if you are laying the cables underground, it is designed for 30 degrees centigrade. If the temperature increases, your derating factor will decrease. Derating factor is decreasing in the sense you have to go for higher cross-sectional area of the conductor. This is effect of ground temperature. So the next is soil thermal resistivity. Generally, soil thermal resistivity is one parameter we consider, but most of the cases, soil thermal resistivity will be considered like a 150 because there is no stringent proper values, proper guidelines to make this soil thermal resistivity. So that's the reason we just by default we take like a 150 degree centigrade centimeter per watt. This is soil thermal resistivity. After that, the next derating factor is the design margin. Design margin is very simple. Generally, what we do is design margin is only for the design engineer's safety because any equipment sizing calculations, any equipment, it could be a cable, a transformer, battery, whatever the equipment sizing calculations, we keep 10% cushion. Always we go with the 10% higher size so that any unforeseen cases, if you ignored, that unforeseen cases will be covered in this 10% design margin. Design margin is purely for the safety of design engineers, whoever is doing the sizing calculations. Because if your cable size is somewhat higher side, it's okay, no problem. But if it is overrated, it is not a problem. But if the cable size is underrated, then what happens when your load is running under full load condition? Then peak current is flowing through the conductor, your cable will get damaged. Then consequences would be very severe. That's the reason when you are doing any equipment sizing calculations, we consider design margin will be 10 to 20%. It depends upon the client requirement. If no client is telling anything, generally we go with a 10%. If client is very specific, then we go with the 15%, 20%. It depends upon the requirement. So these are the factors. 10% design margin is considered, hence for corresponding to design margin, 10% means 0.9. 0.9 means we are taking all these derating factors in the denominator. That is the reason it will be 0.9. So what are the derating factors we consider for underground? One is like group rating factor, depth of laying, effect of ground temperature, soil thermal resistivity, and design margin. 5 derating factors are considered. Yeah, it depends. I'm telling you, Sachin, and that's what I'm telling. Like if you are country to country, place to place, project to project, client to client, this design margin will change. Okay, when you are in Rome, we should be like a Roman. Very simple. When you are working in US projects, you have to follow the US standards. If you are working for European standards projects, you have to go with the European standards. Okay, yes. So this is 10% is the design margin. So overall design margin, like what are the derating factors we are considering for above the ground cable? For above the ground cables, we are considering three factors. There is like a group rating factor, effect of air temperature, and design margin. These are the three factors we consider for above the ground cables. And so that's how we decide current carrying capacity of the conductor. Okay, now we have two parameters. For LT outgoing cables, we consider two parameters. That is current carrying capacity and voltage drop. Now we need to know how to decide the voltage drop. How to decide the voltage drop. So here, the point is calculation of voltage drop is very simple. But why should we consider this voltage drop? That is the point here. Generally, if you look at any SLD, it will be like your voltage we consider starting from transformer. Okay, and as I just shared that SLD, just a minute. So this is the SLD. For example, what happens here? Yes. So in this SLD, what happens? Your output LV side voltage we took like a 433 volts. Okay, and when it is 433 volts, and your voltage regulation, for example, at this transformer, if I'm limiting the voltage, voltage regulation is nothing but voltage drop. I'm taking like a 2% is the regulation in the transformer. So ultimately, what is the criteria here? Because we are going to give input to this various, like for example, this is a borewell pump. So this borewell pump is like 1.5 kilowatt. So the borewell pump will work with the 415 volts plus or minus 10%. So your motor operating voltage is plus or minus, allowable voltage will be plus or minus 10%. So when it comes to the load point, your voltage four should not be uh, greater than 415 volts minus 10%. If the voltage drop is going below minus 10% of the nominal voltage, then what happens here? If your voltage decreases, the current will increase. So you should make sure if the current increases, what happens again? Whatever like your connected equipment will get damaged because of overheating of the conductors and all. So that is the consequences of going under voltage. Okay. So generally your conductor size depends upon current carrying capacity and insulation decides based on the voltage. If the voltage is increasing, then your insulation fails around the conductor. If the voltage is decreasing, then current will increase, which makes overheat of the conductor again, which impacts on the insulation around the conductor. Ultimately, under voltage condition or over voltage condition, both the conditions are not safe to the system. So your voltage range should be within the limits. So to keep the voltage within the limits, we'll make sure the voltage drop is within the limit at the load side. For that, we do the voltage drop calculations. Am I clear with all of you? So whenever you are doing any cable sizing calculation, based on the cable length, we have to make sure the voltage drop is within the limit. The voltage drop is the difference of potential between any 2 points. This voltage drop may be caused by a resistor, inductor, or a capacitor in case of AC. Okay. So now I just want to tell you what formulas we use to calculate the voltage drop. Okay. So generally for three phase, because most of the industrial loads are three-phase loads. For three-phase loads, your percentage voltage drop. This is here. Only this root 3 IL. This is not the formula for normal voltage drop. Okay. Percentage voltage drop will be like a divided by the number of runs per phase multiplied by the voltage. That will give you the percentage voltage drop. Yes. See, generally what we do, if the connected load is the motor load, for motor loads, we consider two voltage drops. That is like a starting voltage drop and running voltage drop. There are certain criterias in cable sizing in electrical system also. So I'm telling you here the generic way of doing the calculation, guys. I'm not taking any specific criteria. You should understand that. Okay. So let us understand first the generic criteria. Once you understand that, then you can understand the scenarios with respect to the connected load. Okay. So first you understand this is the formula we use for percentage voltage drop for three-phase application is root 3 IL R cos pi plus X sin pi. Here R is the resistance and X is the reactance. L is the length of conductor and VLL is the voltage and IFL is the full load current. Okay, so this is the formula for voltage drop for three phase and this is for single phase. You please note down these formulas. This will be very important for upcoming calculations. So percentage voltage drop for single phase cable, like it will be 2 multiplied by IL R cos pi plus X sin pi divided by number of runs. So, and that is for AC and this is for DC. If your application is a DC, a connected load is a DC load and you are doing the cable sizing calculation for DC application. So this is a formula for voltage drop for DC. So generally for DC, your power factor will be unity. That's the reason cos pi will be 1 and sin pi will be 0. That's how your formula becomes like this. So these are the formulas we use for three phase and single phase AC and DC application. So that those are the parameters we decide. Parameters decide LT cable, LT outgoing cable. Now we need to understand the parameters for HT cable sizing calculation. I'll just for HT cable sizing for high tension HT cable sizing, the first parameter we need to know is the short circuit withstand capacity. Okay, so we have to decide the conductor size based on the short circuit withstand capacity. And next, you have to make sure the same conductor can withstand based on the current carrying capacity. And also, we have to make sure the voltage drop is within the limits. Okay, these are the three criteria. Now, so let us see like how to decide the cable size based on the short circuit withstand capacity, guys. Because first parameter you have to know like area of conductor is equals to, this is also very important. Area of conductor is equals to ISC multiplied by root T divided by K. ISC multiplied by root T divided by K is the area of conductor. Okay, here in this A is the area of conductor, cross-sectional area of the conductor. ISC is the short circuit current. T is the fault clearing time and the K is the material constant. So now let us see what material constant in the sense it depends upon the conductor, whether you are going with aluminum conductor or copper conductor depends upon the conductor. Here K factor will be defined T is the fault clearing time. Generally, the maximum fault current of the system shall be taken. The breaker interrupting current rating noted. See, generally material constants we take. The value of K will be depends upon the conductor. So for insulation, for PVC insulation, for aluminum and copper, if the insulation is PVC around the conductor, then for aluminum conductor your K factor will be 72, and for copper conductor your K factor will be 112 amperes per meters mm square. This is the K factor, material constants with the PVC insulation. If it is a XLPE insulation, because in the power system, power cables, majority cables are given with the XLPE. So for XLPE insulation for aluminum and copper conductors, for aluminum your K factor will be 92, and for copper your K factor will be 143 amps per mm square. This is also very important. You please remember this. Okay. So now, what are the K factors for PVC? Aluminum it is 72, copper it is 112, and if it is XLPE insulation for aluminum it is 92, and for copper it is 143. So you please remember these values now. And the fault clearing time. Why we are saying fault? Because what is the formula here? Area of conductor is equals to ISC into root T by K. So K factor we have taken with PVC, aluminum and copper, XLPE, aluminum and copper we have say taken like a 72. And what is the copper? Aluminum it is 92 and it is 143. This is 95 or something, isn't it? K factor. This is for K factor. Now we have to take what should be the time, what should be the fault clearing time. Depends upon the scenarios. So fault clearing time is considered in such a way. So fault clearing time we consider 0.2 seconds for motor feeders and transformer feeders. Fault for LTF, this is okay. Fault clearing time for motor and transformer feeder applications. Your fault clearing time we take 0.2 seconds. And the fault clearing time we say 0.6 seconds for plant feeders, that is outgoing feeders. And the fault clearing time we take incoming feeders we take 1 second. Depends upon the scenario, the fault clearing time will be considered. Okay, so this is we discussed fault clearing time, material constant to decide the conductor size based on short circuit withstand capacity. Okay, here generally I'm just going bit in depth into the concept for HT cables. For HT cables, what happens? We use two types of cables. One is like a earthed cables, and the second one is unearthed cables. So earthed cables and unearthed cables depends upon your system. Whether your system is the earthed system, we go with the earthed cables. If your system is the unearthed system, we go with unearthed cables. So I just want to make you understand very quickly, very simply, earthed and unearthed. Generally, in the for the earthed system, your VL is equals to, for earthed system, your VL is equals to root 3 V phase. This is for earthed system. And for unearthed system, your VL is equals to V phase. So what happens here? For if your system is solidly earthed system, then your phase voltage is going to reduce by root 3 times. Means when the phase voltage is reducing by root 3 times, in the sense insulation, you can save the cable cost in terms of insulation when you are going with earthed cable. If your system is an unearthed system, your phase voltage is equals to line voltage. Obviously, what happens? Which cable size will be bigger one with the same cross-section area of the conductor? earthed cable size is bigger or unearthed cable size is bigger? Guys, I need answers from you. Which cable cross-sectional area of the, which cable size, cable diameter? Because in case of unearthed cable, the amount of insulation around the conductor shall be equals to the line voltage. Okay, that's the reason unearthed cable size will be bigger one. Unearthed cable size will be bigger one compared to, obviously why unearthed cable size is bigger? Because of amount of insulation around the conductor. Okay, so which cable is economical, earthed cable or unearthed cable? With this explanation, which cables are costly? Earthed cables are costly or unearthed cables are costly? Okay, unearthed cables are costly. You're right. Because the amount of insulation around the conductor is higher side in case of unearthed cables. So you should be very careful and you should be very cautious, because if for earthed system you can go with unearthed cables, but for unearthed system if you go with earthed cables, your insulation fails. Okay, so you have to be very careful. Yes, you have to be very careful which where you have to go with the earthed cables and where you have to go with the unearthed cables. That is very important, guys. So this is like a earthed system I explained, and obviously for earthed cables your phase voltage will be root 3 times of your line voltage. For unearthed cables, your VL is equals to V phase. So your phase conductor insulation will be equals to the line voltage. So again, like if your system is a solidly earthed system, there you have to go with the earthed cables. And if your system is unearthed system, for example, you take the transformer, if your transformer is somewhere like this is a transformer. Okay, this transformer, let me take, this is a delta and this is neutral, is solidly grounded. If it is neutral is solidly grounded, then if it is, let me take 33 by 11 kV is the transformer. So here you can go with the earthed cable, 11 kV side, because this is solidly grounded system. But 33 kV side, you have to go with the unearthed cable, because delta side, it is not connected to the ground. It's a very simple example to make you understand. Okay, so it is up to your choice. Sometimes people, instead of taking the risk, all the cables people go with unearthed cables. Then your system will be very safe, but it will be very costly. It depends upon the application, depends upon the commercials. You have to move forward in your projects, guys. Yes, yes. Now, so if we use earthed cable in unearthed system, it may be chances of insulation puncture. Okay, so unearthed cables are used. Such type of cable is used in 6.6 kV system where resistance type. Generally, for 6.6 kV applications, we go with like resistance like NG. We use NGRs, neutral grounding resistors, for the transformers. Where we use neutral grounding resistors for the transformer, there you have to go with the unearthed cable. This is a very, I'm telling you, Malesh, unearthed cables are insulation. The amount of insulation will be equals to line voltage. Your unearthed system, VL is equals to V phase. So obviously, for example, if it is, let me take 132 kV cable, 132 kV cable, unearthed cable, let me take. Unearthed cable in the sense, the insulation around the conductor shall be suitable for 132 kV. The same 132 kV cable, if you are going with the earthed cable, okay, 132 kV earthed cable in the sense, your V phase, your V phase is equals to VL by root 3. So what is the voltage around the phase? 132 by root 3. This is somewhere around 69 kV is the voltage. So we are taking insulation for only 69 kilovolts in case of earthed cable. If the same cable is an unearthed cable, the insulation shall be considered for 132 kV. That's where your system will become very costly. Understand? Yes. So this is the difference between earthed cables and unearthed cables. Now we'll see the calculation. I'll just, guys, it is taking some time. I'll take 10 more minutes time. So once I explain, I'll just wind up the session. Yes. So I'll take you through one calculation for, yes. So here, guys, let's see some examples of, we'll see first HV cable size, HT cable sizing calculation between 33 kV isolator and a power transformer. So in this case, I'm taking the short circuit withstand capacity, or you can say it's a fault level. Fault level, I'm considering 31.5 kA for 1 second. And your transformer rating is 10 MVA, 33 by 11 kV transformer. In this case, we have to understand the scenario how to do the cable sizing calculation. First thing is, this is a HT cable sizing. So the first parameter, step one, we have to decide the area of cross section of the conductor is equals to ISC multiplied by root T by K. So I'm taking copper conductor. If you consider conductor is copper, then the K factor, material constant factor is 143. Then if you, and this T is the time constant for motor feeders and transformer feeders. I told you that your short circuit withstand time will be 0.2 seconds. So we substitute the values. ISC is the fault level. Fault current is 31,500 amps. K is copper 143. So you will substitute all the values. Then see 31.5 kA. I just assume again to get this 31.5 kA, you have to do fault calculations. Short circuit calculations by using per unit impedance method. There are various methods and various softwares we have. So in upcoming sessions, we may tell you like about this fault calculations and all, guys. So now I'm just assuming if the fault system fault current is 31.5 kA, then what is the conductor size? So for 31.5 kiloamps, 0.2 seconds time with the copper conductor, your required cross-sectional area of the conductor is 98.5 square mm. So when it is 98.5 square mm, the nearby, you should go for the next higher standard size. That is 120 square mm is the conductor size. So we have selected here single core 120 square mm copper conductor per phase, or you can mention 3 runs of single core 120 square mm copper conductor with XLPE insulation. It means you have to mention 2XY cable. 2X is a XLPE insulation, Y is a PVC outer insulation. So as it is a copper, we don't write A. 2XY cable you should mention. Okay, this is 120 square m. We have arrived based on the fault current. Once you have come up with the 120 square mm, we should also check whether the 120 square mm cable can withstand for the remaining two parameters. One is like a current carrying capacity, and the second one is voltage drop. These two parameters also shall be satisfied by the cable. Then only whatever the selected cable is suitable. Clear, guys? Is this clear to all of you so far? Yes. So, are you guys with me? Just can you say yes in the chat box? Because the human tendency is after 1 hour, people are going into sleepy. So, I just want to go vain of this time. Okay. This is very important. This is step one. And the step two is the same. I'm checking the current carrying capacity, checking for the cable size considering current carrying capacity, guys. Your full load current, your transformer capacity is 10 MVA and your voltage is 33 kV. We are just calculating the full load current is 174 amps is the full load current. And here I told you this is the full load current. Now we have to consider the cable size based on the current carrying capacity. To consider the cables based on the current carrying capacity, you should know what is the derated current. What is the derated current of the cable? For that, I'm just considering my cable is laying underground. When the cable is laying underground, what are the factors we consider? Grouping factor, depth of laying factor, ground temperature, soil thermal resistivity, and design margin. So what I'm doing here, grouping factor, I'm considering single core cable. We are laying 3 single core cables. We are laying in trefoil. Trefoil in the sense, this is called trefoil. We just make like this. Trefoil spacing and 150 mm is the spacing between the conductor. Okay, and depth of laying, we are just laying the cable 1.8 meters below the ground. Generally for 33 kV, what should be the depth of laying for 33 kV, guys? What should be the depth of laying for 33 kV? Depth of laying for 33 kV should be 1050 mm. Okay, you should not forget. This is very important. But here we have laid the cable at the depth of 1.8 meters. When you're going below the ground, the pressure on the cable increases. When the pressure increases, your conductivity will decrease. So that's the reason we just consider the depth of laying is 0.96. I'll give you the reference, don't worry. And the ground temperature is 30 degrees centigrade, I'm considering here. And what else? Soil thermal resistivity here. These are the proofs how we are taking the factors. This is the group rating factor. I'm going with like 33 kV cables and we are just maintaining the space 150 centimeters between the conductor. Then that's how 0.82 is the derating factor as per the cable manufacturer catalog. And the depth of laying, when you are going depth of laying 180 or more, 180 centimeters or 1800 mm, more than your derating factor shall be 0.96. And for air and ground temperature, this cable is designed for 30 degrees centigrade. That's the reason it is 1. Overhead transmission will not comes under this. That is a different story. Overhead transmission is not the cable sizing. Overhead transmission is the transmission line profiles and all we have to consider. That's a different criteria, Malish. Okay. Yes. So these are the derating factors we consider. And soil thermal resistivity, I'm taking 1 and we are taking the design margin is 10%. We are going the design margin 0.9. So with this all, your overall derating factor is 0.699 will be the derating factor. So with this, derated ampacity is equals to the full load current divided by the derated current. So your derated ampacity is 250 amps. So what does it mean? We have to select the cable size. We have to select the cable size for 250 amps derated ampacity from the cable catalog. So variation soil thermal resistivity is okay. Considering derated ampacity 250 amps, which is the cable size is required. Whatever you have selected, the 120 square mm cable can withstand up to 300 amps, but your derated ampacity is only 250 amps. So hence the selected cable size, single core 120 square mm. This we are going with the earther cable. 120 square mm copper conductor is satisfying the condition, which can withstand for the maximum derated current. So 120 square mm conductor is satisfied two conditions. One is current carrying capacity and short circuit withstand capacity. The next is you have to check the voltage drop. Here, this is the nominal size of the conductor. 120 square mm can withstand 300 amps when you are laying the cable in ground. Guys, is it clear so far, all of you? Am I clear with you? Yes, thank you. So, this is the next we have to check the voltage drop of the cable. So, for this is a three-phase application, the voltage drop formula for 120 square mm, your resistance is 0.196. 120 square mm, your AC resistance, copper is 0.196 ohms per kilometer. And reactance is taken like this. Approximate reactance for 120 square mm cable, armored earth cable 130 ohms per kilometer, and number of runs are 1, full load current is 174 amps, and the length of cable is 65 meters, and the running power factor is 0.95. With this, you substitute all the values, your running voltage drop, because here our application is a transformer. So your running voltage drop will be 0.202, which is generally your voltage drop shall be less than 3%. That is how we consider in cable sizing. So here your running voltage drop is just 0.202 percentage, which is very less than 3%. So whatever the cable you have selected, single core 120 square mm copper earthed cable 33 kV is satisfied all the conditions. It is satisfied current carrying capacity and voltage drop. So this is how we decide cable size for HT applications. So guys, I'll give you one more scenario for LT cable sizing calculation, which makes you understand in a very simple way. So please bear with me for 5 more minutes. So I'll finish it off because if I don't tell you this, then it's like it seems like for me, I'm not doing justification for this workshop, guys. So I'll just explain you very quickly. Like I'm doing the cable sizing calculation. Is it okay for all of you? Shall I continue with LT cable sizing calculation or shall I close this? Yes, thank you so much. Now, so what I'm doing here, I'm taking 55 kilowatt load, 55 kilowatt motor I'm taking, and the voltage is 450 volts. For this 55 kilowatt motor, your running power factor is 0.94 and starting, because for motor you have two power factors, starting and running power factors. So starting power factor is running power factor is like a 0.94 as per the motor data sheet, and starting power factor will be 0.2. We are assuming the starting power factor will be 0.2, and I'm taking the motor efficiency is 0.93, and the length of cable from starter to your motor is 380 meters approximately. Then I told you like LV outgoing cables size decided based on current carrying capacity and voltage drop, isn't it? Yes. So your full load current for 55 kilowatt motor, your full load current will be like 87.52 amps. And as we are laying the cables below the ground, these are the group derating factors, with the grouping factor, depth of laying factor, group temperature, and all. Okay. So ground temperature and all. These are the cable catalog sheets. Like we are laying number of cables, when you're laying 8 cables by touching each other, then your group rating factor will be 0.46. And this is how the depth of I'm laying the cable below 750 mm below the ground, as it is a LV cable, then the derating factor is 1, and the ground temperature I'm considering 40 degrees centigrade, then it will be 0.91 is the derating. So soil thermal resistivity is 1 and design margin is 0.9. The overall derating factor will be 0.376 is the overall derating factor. Then your derated ampacity is equals to your full load current divided by the derating factor. So derated ampacity is 232.3 amps. So you have to select the cable size for derated ampacity, that is 232.3 amps. So for derated ampacity 232.3 amps, your selected cable size is, guys, here you have to make a note of it. Why I have taken 3-core cable here? Because the connected load is a motor. So motor will have 3 phase, only R, Y, B. That's the reason I took 3-core cable. For motor loads, we go with the 3-core cables. And 3.5 core and 4 core is used for distribution loads. Okay, that's the reason I took 3-core. 150 square mm is the conductor which can withstand up to 249 amps below the ground. So as you have selected this conductor, you should also here single run of 3-core 150 square mm A2X FY cable. Aluminum conductor, 2X is the XLP insulation, F is a flat armored, Y is the PVC outer insulation. So and once you selected the cable size based on the current carrying capacity, we should also check the voltage drop. For motor applications, you have to check 2 criteria. One is starting voltage drop and running voltage drop. So for 150 square mm conductor, this is the resistance, reactance, number of runs. These are the parameters, and this is a running power factor is 0.94 and the starting power factor is 0.2. And as 55 kilowatt motor is connected with 55 kilowatt motor is connected to the DOL starter here. That's the reason your motor starting current I consider 6 times to its full load. So now the starting voltage drop, the formula is this one. Current is 6 times to its full load current, and the starting power factor is cos pi is 0.2, sin pi will be 0.97. Your starting power factor is starting voltage drop is like 10.18, which is less than 15%. This is fine, and your running voltage drop should be less than 5%. So if you make sure these calculations later, because I have no time to wait till you give the answers. So running voltage drop is 3.67%, which is less than 5%. So both the conditions are satisfied. Okay. So your starting voltage drop and running voltage drops are within the limits. That's how we are going to select the cable size, that is single run of 3-core 150 square mm A to XY cable is suitable. So guys, this is how we do cable sizing for LT and HT cables, HT applications. So generally for communication cables, we don't consider any parameters because for communication system, your current will be in milliamps. So we don't consider any particular sizing for that. Okay, your communication cable conductor size will be like a 0.5 square mm, 0.8 square mm, something like that. So guys, this is all about cable sizing calculation. So thank you all of you. And if you have any doubt so far, you can ask me.
Yeah, guys, you can unmute yourself and speak. Okay, we have given the access. Please put your questions, or you have anything you can put in chat box also. Thank you.
Guys, we have also shared the feedback link. You can give your feedback.
So I request to all of you, please fill your feedback forms. Whoever is giving proper details in the feedback form, only those are going to get the certificates. Please make a note of it, guys.
And guys, we do also have a course starting on March.
Sir, I have one doubt, sir.
Yeah.
Yes, just a minute. Yes, please.
Sir, actually, what is the voltage drop? Some cable data sheet they mention volt per ampere per meter. Some data sheets volt per ampere per kilometer. What is that meaning, sir?
That is depends upon the length, because when the length increases, your resistance increases, your drop also increase. So in that per meter, they have given the drop with respect to the current. You got it? Where you have seen that?
in the data sheet, sir.
Yeah, but that is a standard voltage drop with respect to their cable catalog, but you should not consider that. Generic way, you have to do the cable voltage drop. That is a better way.
Okay, sir. Thank you.
Yes.
Hello, sir.
Yes.
I have one doubt, sir.
Tell me.
Sir, where we can use 3.5 and 4 cores, especially, sir.
Excellent doubt. Actually, I'm just waiting for this doubt. Actually, good. Generally, in a distribution load side, you have two types of loads, like a balanced load, unbalanced
Okay.
load. Okay,
Yeah.
if your connected load is a balanced load,
Oh, okay.
there you can go with 3.5 core cable.
Okay.
If the connected load is an unbalanced load, there you have to go with the 4 core because most of the distribution loads are unbalanced.
Yes, sir.
Where the unbalanced load condition, your vector sum of IR plus IY plus IB will not equals to 0. That resultant, the unbalanced current will flow through the neutral.
Okay.
So there you have to go with the 4 core cable.
Okay, sir. Okay.
Clear?
Yes, sir. Clear, sir.
And one more thing to all of you is, see, this is a very small bit we explained in this today's workshop. If you want to understand complete electrical system, then you have to join with our regular 2 months job oriented training. So in that training, we give rigorous training along with all the practical scenarios with the placement. Guys, we are associated with 250 companies starting from top MNCs to the small scale industries. So depends upon your interest, depends upon your technical ability, communication skills. We will send you for the interviews. That's how you guys will get the job. Whoever is interested to do core jobs and whoever is interested to learn electrical system design. So for them, HIW is the one-stop solution, guys. So
Okay.
please understand. Any more
Uh,
doubts?
can you tell me the prices of this?
Yes, for our 2 months, 60 days job oriented training is we are charging
Sir,
30,000 rupees.
Sorry, 30?
Sir,
30,000 rupees.
Okay.
Yeah.
Someone is asking question,
sir,
sir.
there's a question from YouTube Live uh,
Okay.
from Raj saying that should we consider variable frequency in derating factor here?
Variable frequency in
Derating factor. Uh,
variable. No, generally our frequency is 50 hertz frequency. You like that will not come consider that is a different case maybe he is asking about, but when it comes to the cable sizing we consider 50 hertz frequency because that is based on 50 hertz frequency only you are getting the power. So variable frequency will not be considered as a derating factor for cable sizing.
Guys, any more doubts from your side? We have shared the feedback link. Please fill the feedback link for your certificate. And if any issues, you can ping on the number. And by Monday, all your certificates will be issued. And for further more details on our job-oriented course, I have the link shared in the chat box. And you can ping me or call me on the numbers that we have shared. And I'm also sharing our social networking sites like our Instagram page, LinkedIn page, and YouTube channel. If anyone has network issues or want to watch this session again, they can go ahead and watch it in our YouTube channel. Please like, share, and subscribe. And if you want to know all the details about new updates about the course and everything, you can check our Instagram page and LinkedIn page.
And I request to all of you,
Uh,
please follow us on LinkedIn page. So for further updates, because in upcoming days, we are going to conduct many more free webinars like this. So that could be more helpful for you guys. Thank you so much.
I
See you.
have a question for you.
Yeah, thank you. Sorry, tell me.
What would be the expected package of the I mean, for the program for
Sorry,
freshers?
your voice is not clear.
So I'm audible right now.
Yes, tell me.
So what is the starting package for a fresher after completing this program?
See, actually, we are trying to get you like a minimum package of 2.4 per annum for freshers. Okay, it depends upon the company and for example, if you have all 70s more above 70 percentage academic percentage, then there are some MNCs called Toshiba, Mitsubishi, T-Mac, and like a Burns and McDonnell. So if you get selected for MNCs, your package will be starting from 3.6 to 5.5.
Okay, actually, I have other work experience, so is it gonna work out here? Will be considering as a pressure.
Sorry, I
And
didn't get your point actually.
actually, I have work experience with the
What
other
is
work.
See, you do one thing, you do one thing. My request to you is you please call us on that number.
Sure, sure.
Okay, so our people will guide you.
Sir, sorry to interrupt you.
Sure.
Guys, any questions regarding the batch, please do call us and get the information in detail. And we support you in all the means. Madan sir, this discussion is purely for the technical queries to be resolved. I request you to please focus on the technical queries on it. Thank you.
Okay, great.
Sir,
Thank you.
there are some more questions on the chat box saying, sir, is the distance of line affects the resistance and conductance of the cable?
Yes, of course. Line length, where like resistance depends on the line length. Yeah.
Okay, sir. I guess that's it for the questions for now. I'll be resharing the feedback link. Please give your valuable feedback. And for any details regarding the batch, you can ping us or call us on the numbers or shared below. Okay. Uh,
I think somebody is in.
uh,
It's okay. Chalo then. Thank you all. Thanks for your time and great patience in connecting with HIW. So
Yeah,
looking
last but
forward.
not the least, guys, please put your queries of technical if you have anything on the feedback link. We would love to answer your questions and mail you the answers. That would help us also to get back. Considering the time limit, we are not able to answer all your questions. Thank you so much for your patience, guys. All your questions will be answered if you put them in your chat box or if you please put it in your feedback link. Thank you, guys. Thank you so much.